Finding the general term and sum of a geometric series. Example 2.21. So this is a series, a geometric series. Again, why do you call it a geometric series? Well, because it is a sequence of partial sums. Okay, so this is our symbol telling us that this is about obtaining the sequence of partial sums of a geometric sequence. And the terms of your geometric sequence are defined by this. This is what you call the general term. So the general term is a sub n is equal to 2 raised to n minus 1. You can use other subscript. You can use I. You can use j. So a sub j is equal to 2 raised to j minus 1. Does this series have a sum? If you were to do the summation, would it converge to a sum? No, it will not. We have a theorem for this. And what we do is we pay attention to the common ratio. The common ratio is 2. The absolute value of 2 is greater than or equal to 1. The sum does not exist. The sum of this series does not exist. How about this? Another geometric series. What is the general term? Okay, so you will look at this. This is the general term. That is the formula that will produce the terms of your geometric sequence. Does it have a sum? Yes. This summation or this series will converge to a finite sum. And we have a theorem for that. It converges to a finite sum because the common ratio is 1/2 and 1/2 is less than 1. A theorem assures us that the sequence of partial sums of a geometric sequence will converge to a finite sum if the common ratio or the absolute value of the common ratio is less than 1. And what is that sum? You know what? That's good about the theorem. It is also telling us what is the sum. The sum is equal to the first term, a sub 1, divided by 1 minus r. So in this case, the first term is 1. The common ratio is 1/2. So the series converges to the sum which is equal to 2. Again, example 2.21, finding the general term and sum of a geometric series. So we are now given a few terms of your geometric series. And our task is to find the general term. So this is like pattern recognition. And from that pattern, we will write the general term, write the geometric series, and get the sum. So what do you think is the pattern that is shown by this series? The first term is square root of 2. So why did it become 1? What did you multiply to square root of 2 so that the next term becomes 1? Well, obviously, it's 1 over square root of 2. Why did the third term become 1 over square root of 2? Well, obviously, we multiplied this 1 over square root of 2 to 1. And we multiply this again to the third term to produce the fourth term. So we can now see here the common ratio, and that will help us write the general term. So this is our general term. Again, you know what? You cannot just write it right away. You have to exercise some caution, and the only way to do that is to recheck it. Okay, so the first value of n is 1. That corresponds to the first term. So when n is 1, when we compute this must match the first term in this series. So when n is 1, this is 0, this is 1, that whole thing is 1. A real number not equal to 0 raised to 0 is 1. So 1 times square root of 2 is that. Okay, we got it. What if n is 2? That's the second term. Okay, so when n is 2, this is 2 minus 1. That is 1 over square root of 2 times square root of 2 is 1. So we got it. We got the right general term. So we now write the geometric series. Okay, so we shall use the summation symbol for that. So this is the geometric series. This is the general term. What is the sum? Well, the sum exists because the common ratio is less than 1. Or in particular, the absolute value of the common ratio is less than 1. If the sum exists, what is it? Well, we will use again our theorem. It is equal to the first term, okay, divided by 1 minus r. And that is equal to, we multiply square root of 2 to square root of 2, that is 2. This series, okay, so this series will converge to the sum, which is equal to 2 over square root of 2 minus 1. Another one. These are the first 5 terms of your geometric series. What is the general term? So this is about pattern recognition. So why did or how did the second term become negative 1 over e? So you multiplied negative 1 over e to 1. Why did the third term become 1 over e squared? Well, you multiplied negative 1 over e to the second term. And upon multiplication, the product is positive 1 over e squared. So you are seeing here that the common ratio is negative 1 over e. Okay, so we already know the common ratio. Let us write the general term. So this is the general term. Again, you double check it. Will this general term produce the first of 4 terms of your geometric series? We'll do it by substitution. When n is 1, so this is 0. This whole thing is 1. 1 times 1 is 1. When n is 2, 2 minus 1 is 1. Negative 1 over e raised to 1 is negative 1 over e. So that's it. Okay? So we got the right. You can continue until you get to the fourth term. So we got it right. We got the right general term. Let us write the geometric series. This is the geometric series. Does it have a sum? Does the series converge to a finite sum? The answer is yes. Why? Because the common ratio, the absolute value of the common ratio is less than 1. And what is that sum? Well, that sum is equal to the first term divided by 1 minus r. Okay, so be careful here. This is 1 minus negative 1 over e. So that becomes 1 plus 1 over e. So we simplify this complex fraction, and this sum is e over e plus 1. So this geometric series converges to a finite sum which is equal to e over e plus 1.